Forget studying harder. Today, we're pulling off a heist. It's a completely legal mark scheme heist to literally steal top marks straight from the Cambridge Examiner's vault for IGCSE Computer Science 0478. We are going to master Denary to binary conversion without a single solitary mistake. Just look at this. A massive, glaring red 0 marks. Ouch, right? This right here is the catastrophic error that completely ruins grade boundaries every single year. I mean, one slipped bit, just one misaligned place value, and your entire calculation just crumbles into pieces. But hey, by the end of this explainer, you are never, ever going to see this red ink on your exam paper. For sure. Okay, let's dive into this. To execute this mission flawlessly, we absolutely need the blueprints. We have to truly wrap our heads around the two very different worlds we're bridging today, which are denary and binary. You know, without this foundation, the whole operation just totally falls apart. First up, decimary. This is the base 10 number system we use every single day. It uses 10 unique digits, 0 through 9, and honestly, why 10? Well, historians and mathematicians theorize it simply comes from our human biology. Ancient civilizations basically started counting on their 2 hands, using their 10 fingers. It's literally built right into human nature.
But, as you know, computers don't have hands. They have circuitry. And that brings us to binary, a base 2 number system. It uses only 2 digits, just 0 and 1. Every single piece of data a computer has to process, whether that's text, sound, or images, it all has to be converted into this binary code to actually be understood. It is the absolute fundamental language of the machine. The whole shebang hinges on this translation.
Now, what's really interesting about this slide is exactly why computers are forced to use base 2. Inside the CPU, processing takes place using components like registers and memory, and these are made up of microscopic transistors. These transistors can either hold an electrical charge which represents a 1 or hold no electrical charge representing a 0. They also use logic gates to make decisions, and those only have 2 options, on or off. There's no maybe in computer science. It's pure physical hardware dictating the math. So how do we translate our human numbers into their machine language without, tripping the alarm? Let's enter the execution phase. I'm going to walk you through a totally foolproof method to convert the Denary number 19 into binary, guaranteeing a perfect execution every single time. All right, so we set up our base 2 place values in a table going from right to left, and we double the value each time. So we have 1, 2, 4, 8, and 16. Now take your time here. We need to hit a total of exactly 19. So first, we turn on the 16, giving it a 1. We only need 3 more to reach 19, so we're going to skip the 8 and the 4, just dropping zeros in those boxes. Then we turn on the 2, and finally we turn on the 1. So 16 plus 2 plus 1 equals exactly 19. Bam! And this brilliantly illustrates our final code. 19 in Denary translates flawlessly to 10011 in binary. It's elegant, it's simple, and honestly, it's totally impenetrable to examiner deductions when you lay it out clearly in a trace table exactly like this. But wait, hold on. Actually, calculating the number is only half the battle. In a moment, I'll show you the exact examiner clue that changes a binary calculation completely. But first, you need the framework that makes this clue blindingly obvious. To decode the examiner's true intentions, we need our inside man. We have to understand the Cambridge exam command words. This is like a secret language printed right on your exam paper, telling you exactly how to unlock the marks you've actually earned.
Let's rapid fire through these. If they say state or define, they want concise, punchy technical points. Describe means give the characteristics. Explain requires the why or the how. Now, pause for a second because these next 3 are where the real danger lies. Compare demands you look at both sides. If they say calculate, you absolutely must show you're working out, or you risk losing the marks entirely, even with a perfect answer. And evaluate or suggest, you must apply your knowledge directly to the specific scenario they give you. Misinterpreting these verbs is absolutely the biggest trap in the entire 0478 syllabus. Let's move to the final phase and see how this builds into our ultimate getaway plan. You know the maths, you know the command words, so now it's time to secure the top band upgrade and escape with the absolute maximum marks possible. So the crucial point is applying this exact 4-step answer framework. First, state the concept clearly. Second, pull evidence or data straight from the question scenario.
Third, apply your scientific reasoning, kind of like those base 2 place values we just used. And fourth, rapid and precise examiner wording. Remember, one distinct technical point usually equals 1 mark. Don't waste time just repeating yourself using different wording. Check out the difference in action here. On one side, we have a flawed, super generic answer. It basically just says binary is zeros and ones. I mean, sure, it's true, but it's incredibly weak. But on the other side, the top band upgraded answer names the exact constraints and uses the exact nouns from the scenario. It explains that the specific memory register mentioned in the prompt uses base 2 logic gates to switch transistors on and off. And that is exactly how you secure the bag of marks. You apply your knowledge to their specific scenario. Mastering this binary conversion strategy and learning these frameworks is just step 1 in cracking the Cambridge Code. To make sure you don't miss the rest of the blueprints, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, do it now, because the stakes only get higher from here. We've safely navigated the CPU's memory registers. We've converted the data flawlessly into ones and zeros. But what happens when these delicate binary codes leave the safety of the processor and face a vicious network topology trap? If your data packets are sent down the wrong transmission media, or they just get caught in a switching error, all this perfect binary gets totally corrupted. You've escaped the mark scheme trap today, but the network heist is next. So are you ready to see how we protect this data in transit? You absolutely have to jump into our next explainer to survive the network paper. See you there.